How many of you are .NET developers here? Oh, that's interesting. In this session, we are going to talk about containerizing .NET applications and running them at scale on AWS. Like you, I was a .NET developer for about 7 years, and in last role, as a software architect, taking care of about 80+ developers, helping them writing great Microsoft applications. I love .NET programming. We have been running .NET applications on virtual machines for a long time. Microsoft did a bit late entry into the container world, but with the introduction of Windows containers, containers are now, with the introduction of Windows 2016 servers, containers are a first-class citizen on Windows platform. A lot of our customers ask this question, can we run containers at scale on AWS? Windows images are big. It's about 10 GB for the Windows core image. How about running them on production environment? Can I do continuous deliveries on them? How about the tooling support? I love Visual Studio. I love Microsoft Team Foundation Server. How can we integrate them with AWS? In this session, what you are going to learn is how you can easily containerize your .NET applications and run them at scale on AWS. So what I'm going to do now is to first containerize a very simple console application using Visual Studio. For the best interest of time, because we have about 30 minutes, I have recorded them, cut them, and just going to give them only what is needed. Because image download, upload, cluster refresh, health checks takes time. So here I'm in my Visual Studio. What I'm going to do now is to create a very simple console application, a batch application. Give it a name, something like my batch application, create it. And then what I'm going to do is to paste some code. All what that code is going to do is to spin up multiple threads, about 20 threads, and then print some random numbers into the screen. So this it's used the task parallel library to print these numbers, so nothing magic. What I'm representing here is a very classic batch application that you can containerize. So once I run this, all what it's going to do is to print some random numbers into the screen, right? So to containerize this, all what you need to do is to right-click and click Add Docker Support, and it's going to add this file called Docker file, which will identify what kind of image that this application is going to be based on. So if you look at the first part of this code, it says, hey, base this one out of .NET Framework image. So Microsoft regularly publish this image in repositories like Docker Hub. So once you build this, what will happen is, if you try to run it, Visual Studio is going to go there and then download the image if you don't already have it. Let's say this is happening in a continuous integration system. Only delta changes are being pushed. So what will happen is that it's going to download this image. With the magic of video editing, I'm not going to wait until all this image content is downloaded. And so once you fast forward, what will happen is it will kickstart this, the image and then run some remote debug, and you get your favorite debug points hit. So debugging a console application is same as when you containerize it using your favorite Microsoft tools. Great. If you start PowerShell and then type Docker PS to get the running containers, so behind the scene, the Visual Studio has built this image, spin up a new container, and you can use the same tool that you have been using. Containerizing .NET ASP.NET. So these are full .NET full framework applications. It's also easy. Just click Add, and then click Add Docker Support, and then you can easily containerize this ASP.NET web application. So this could be your web API application, or this could be your ASP.NET MVC application. So behind the scene, what it's going to do is to base this solution out of ASP.NET image, which has a IIS installed, your .NET Framework installed, and it's going to spin up a container, start IIS, and then run the remote debug behind the scene. Interestingly, this is not going to run on your local host. It's going to run on a special NAT network. So you can actually run multiple websites if you want. So debugging of this application is also super easy. All what you need to do is to, let's say, make some modification, and it will get reflected. As long as you don't need to make any modification that will end up in that you need to compile, if, let's say, you are going to make some HTML changes, style changes, or JavaScript changes, and want to get the image built and tested, all what you need to do is to make this change and then refresh it, and it will get represented in your web application. So the debug points you get hit, and also you get the changes that you want without restarting IIS or restarting your container. So what we learn here is that you have this IIS website, and there are like 3 or 4 web applications running. So this may be your multiple web application, your web API running on different applications. So this will convert into different containers very likely. So what we'll have is that you have this the Amazon ECR, and you are going to get these different applications into your local host and then run them. If you have different teams, for example, working, you can create a continuous integration system that will build these containers and publish into the test server. And then you will have, you can point your API proxy into this central location. So far, what we study is how about running a single container. So running a single container is super easy. We can even run it manually. The challenge comes when you try to run hundreds of containers or thousands of containers. You need to think about finding the right resources. For example, if your container demands 200 megabytes of memory, you need to find a host with that amount of memory. Let's say you have a situation where you need to start 5 containers 2 a.m. in the morning. So how can you do that? This is where the challenge comes in. And that's why we built Amazon ECR and Amazon ECS. ECR is yet another container repository, like Docker Hub. The only difference is that you can easily integrate the identities with AWS Identity and Access Management. So you can say, hey, these are my production repository. Only production servers have access to it. Amazon ECS is an orchestration engine. So there are a lot of orchestration engines like Kubernetes. So ECS is yet another orchestration engine. So how ECS works is that you have this concept called a cluster. So cluster is an abstraction over some kind of memory, CPU, and storage. And then you create this thing called a task. A task is something where you define the set of containers you want to run. So it could be your IIS website, your web API, your SQL server. SQL server is now also available in containers. And the set of constraints. So it can be, hey, this is a super important finance application. I don't want to run it in the same host that the HR application is running. So you can define those constraints. So once you define those constraints, you can also define the resource demand. Hey, for this special application, I need half a CPU, and I need 500 megabytes of memory. So once you define this task, the next step is to define something called a service. So service define things like how many tasks to run. Let's say I have a web application that I need to have 2 tasks. Then you can define things like, what's the deployment strategy? Hey, do I want to do blue-green deployment, canary deployment, some rolling deployment? So everything you can define in the service. And finally, the auto-scaling strategy. You can say, hey, once you reach 80% of the CPU utilization, spin up some more tasks. So ECS has the built-in intelligence, once you have this one, to deploy them. For example, in the case of bin packing, you can say, hey, first fill one host with containers and go for the next host. In the case of balance spread, you can say, I have 2 hosts in 2 availability zones. Spread your containers evenly across them. So if one host fails, you still have some running set of containers. You can also define your custom placement algorithms if you want. That's also available for you. So once you have this set of services, you may have something like HR application, my finance application, marketing application. You can easily place them on the cluster and schedule them and run them. So what we are going to do now is, again, deploy them into ECS, and then see how you can easily run these applications on ECS. So here I am in my AWS console. For the best interest of time, I have recorded them. I have the console already created, the cluster. So you go to the repositories, and you create a sample repository. So let's create a repository. This is nothing more different than creating a Docker Hub repository. So I give it something like my batch application repository. And you create the repository, and gives you a set of commands that you can execute to publish an image. So all what you need to do is to copy this image repository URL, and then go to your PowerShell, and then punch in some commands. So if I type Docker images, behind the scene, Visual Studio or your continuous integration has built this thing called my batch app latest. So that comes as part of MS build. You log in into ECR, so login is successful. You tag the Visual Studio built image with the full URL of ECR, and then you call Docker push. Important thing here is that although Windows Server Core image is about 10 gigabytes, only the delta changes are being published. So you don't need to worry about a large upload time, especially if you are doing continuous integration. So I have my image now in ECR. The next obvious step is to go and then create a task definition that I discussed about. So go to task definition, create a task definition. Super easy, give it a name. You can define a permission if you want under role. Here, in this case, I'm not going to define one. And then you add containers. Adding containers, you can add multiple containers, your SQL server, your IIS server if you want. So define the container name. In this case, I'm going to run my batch application, the famous EXE application that I created a moment ago. Give the image URL. So that can be your private repository, Docker Hub, or in this case, I'm using Amazon ECR URL. Give how much memory you want. So this will make sure that ECS find a cluster resource that can place this container with that amount of memory. CPU units. So one CPU unit is 1024. So if you want to give a fraction of a CPU, let's say quarter of a CPU, you define something like 256. So once you do that, you can define things like the command. So in this case, I want to run my batch application. So in this case, it's going to be C app my batch app exe. So that's what I want to run. You may run IIS as part of it. So you define the command that you want to run, and then, of course, you can define environment variables if you like. You can define your custom DNS servers. You can also define mount points. For example, if you want to mount some data volumes which your containers want. Maybe you want to have some configuration shared across multiple containers. You can do that. And then, of course, you are going to define a log location. Now, these containers are not going to stay for a long time. You run the batch application about 5 minutes, 10 minutes, and after that, they are going to die. So you need to have some mechanism in place to bring this container, the logs, into a centralized location. In the case of AWS, it's going to be the CloudWatch. So define the location and click Add. If you want, you can add multiple containers. In my case, I don't have any. So just everything is done. Click Create. Once you click Create, it's going to create a version of a task. So you can run multiple different versions of the task on the same cluster. So I have the task definition now created. The next step is, obvious step is to run it on my cluster. So I already have 2 tasks running on my cluster. So next step is to go there and then schedule this task on my cluster. So go to the task and click Run New Task. So I already have 2 tasks running. So this may be a different version of my previous application. Run a new task. And how many tasks I want to run? I want to run 4 of these tasks. What's the placement algorithm? So it can be balance spread or bin packing, which we already discussed. So in this case, I'm going to select balance spread and then run the task. So this will kickstart the task. So it wants to go there and then download these images if the container host does not already have it. But here, in this case, I have fast-forwarded it. So the images got quickly downloaded, and after a while, they will start. So now you have your batch application running behind the scene. So they're going to output some content, the console output. How can you collect it? So if you go to the CloudWatch, the console output I'm now capturing. So if these containers die for some reason, you still have their logs output. So let's create a service now. Creating a service is also super easy. Give it a name, how many tasks you want to run. In this case, I'm going to run 4 tasks. So the service will make sure that regardless of what happened to the container host, that it will always start this task in a different host. I'm not going to load balance, click next, 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 and create the service. So what will happen is that your desired count of task is 4, but the running count is 0. Service will understand that there's a deviation from that desired state, and it's going to spin up new containers automatically on the cluster. So after a while, these pending containers will start at some point. Keep refreshing. So 2 have already started, and now you have the 4 running tasks. Now, this is a healthy state on the cluster. So you have the 4 batch apps or your 4 web apps running now. So to simulate some kind of a failure, let me go there and then click. I'm going to stop them. So this is just simulating a failure of containers. So I'm going to stop 2 containers or the 2 tasks so that my desired state deviate from my running state. So if you refresh now, you have only 2 tasks running. So what will happen is the service will identify, hey, there's some deviation on my desired state, and it's going to spin up some new containers and bring this cluster into a healthy state. So it's already started 2 tasks. Now they're all in a healthy state. So that's how you manage this kind of special deployments on AWS. So far, what we learned is about deploying and running these applications on AWS. But you also need to think about bringing the monolithic application as it is into AWS or cloud native or containerized environment is not the best approach. You need to do a bit of refactoring and modernization. The reason for that is your environments are different. Sometimes they auto-scale. Your web server is going to live only for 5 minutes. Your batch application may run for 10 minutes and going to die. So you need to apply certain architectural patterns and design to make sure that you bring these logs and to manage them in a proper way. So what are the best practices you can use in this kind of an environment? First thing, the logging. How can you do the logging? The good old Windows event logs. You write into Windows event logs. There's no magic code. You use system diagnostic namespace. Your application write into that. CloudWatch agent can read them and then pump them into CloudWatch. Method number 2, performance counters. Time series data. Write into performance counters. CloudWatch agent reads them, send them into Amazon CloudWatch. Method number 3, typical login. We love these libraries, nlog, log4j, Microsoft Enterprise Library. Who use them? Hands up. Wow, that's great. So what we are going to do is write into a log file, no under. You just, Amazon CloudWatch is going to read them and then pump them into Amazon CloudWatch. Method number 4, use CloudWatch API. All AWS APIs are exposed as .NET Framework. Just pump them into CloudWatch. Use custom log providers. So if you are using any of these libraries, you can extend them with your own provider. Just use our API, create your own provider, and write directly into Amazon CloudWatch. If you are too lazy, you can still have NuGet packages available for these libraries. And also what we already saw, so things like capturing the console output, you can easily do with the AWS provided interfaces. The next challenge is keeping data configurations and secrets. So let's say we have a container host. So how I'm going to share the data across multiple containers. So I have running containers on the container host. You share a fault in the container host that you can share across multiple containers. Same for the web config, app config, your XML file, your JSON file, your YAML file. All the configurations can be shared across multiple containers using these mounted volumes. Good old environment variables are still available. You can keep your connection string, your passwords on that, and access it if you want with the environmental these libraries. Now, keeping your password is not the best way as an environment variable. So what can you do? That's where the simple system manager comes in. So you can define scopes in that. So for example, this is my production database password. And once you define these secrets, it will be encrypted and kept. The next step is, of course, to access them. So how can you access it? So you have this container or the task that you want to access them. You define a policy. In the policy, you say, hey, this is the scope, production database password. And anybody who has this permission can access it. And you attach this one into that task. And the task, when it is running, it will assume that permission, so you can easily access it. So you can access it with PowerShell if you want, as long as it's running inside the container. As long as this code segment is running inside the container, it will have that permission automatically. So you don't need to do any magic to access it. If you don't have access, it will throw an exception like this. Scaling and service discovery is the next thing. How can you do that? So I have these Contoso API and Fabricam API that I need to expose. You can do it 2 ways, through application load balancer or Route 53, which is our DNS server. So when the container starts, they can automatically register against these services. Same when the container dies. So when the container dies, it automatically deregisters. You don't need to write extra code to do that. So once it happens, you will have your service working regardless of how many containers are running behind the scene. To give you an example, let me show, this is a demo again, which I recorded. It takes about 5-6 minutes to do this. So I pre-recorded it and then fast-forwarded it. So I have 2 containers registered against my DNS server, Route 53. So what I'm going to do is to auto-scale this. So instead of running 2 containers, I'm going to change the service to run 6 containers. So I type 6 and then update the service, next. So the service is going to start 6 containers. And AWS automatically registers these containers against your DNS server. So you can do the normal DNS lookup if you want to find the IP addresses of these containers, especially if you are running other than HTTP protocols on these containers. You may need to have the IP address access. Same for the load balancers. So if you go into your load balancer, you can find that the containers are automatically registered here. There are 6 healthy container instances that are running behind the scene. So if you decommission or if you change this one from 6 to 2, for example, and the next step, what will happen is the service will automatically update, and you only have a few healthy, 2 healthy containers and few draining one. So far so good. Everything is working fine. What will happen if something fails? So you are going for this microservice design. You are going to these wonderful web API endpoints, REST APIs. What if the service happens when you are doing that $1 million transaction? So there are different ways you can handle it. The first approach is to use exponential backoff. Let's say you invoke your web API endpoint, and then it fails. You can keep trying, but it doesn't make sense to keep adding load to a service that is already failing. So the best approach in that case is you wait for 2 seconds and then try it again. Doesn't work? Wait for 4 seconds and try it again. Doesn't work? Wait for another 16 seconds and try it. So you can do that exponential backup and then again try it again. If you keep failing, it doesn't make sense to keep wait and then fail. So let's fail fast, and that's where the circuit breakers comes into picture. So you apply something called a circuit breaker, where if you fail, let's say 10 times, okay, fail fast, throw an exception. Even, let's say you keep failing, let's say there's a big problem and there's a disaster, it keeps failing forever. Let's say you can direct that traffic into a static web page. So that's where the fallback plan comes into picture. You can code this with your Visual Studio C#. You can write all the thread synchronization to do that. But luckily for us, you have a library called .NET Poly library. So this .NET Poly library is not the same Poly library that AWS Poly is, which is for the speech synthesis. So this is an open source project, great library, where you can define things like the retry policy. You can say, hey, if this fails for two times, just wait, apply this recycle, this retry policy, and then try it again. You can define the circuit breaker policy. So it's a very fluent API. You can declaratively define it, and it's a very small number of codes. You can easily define these microservices or failback policies within this library. Go and try it. So the other approach is the challenge is doing continuous deliveries. So we discussed about some best practices. The other thing is, of course, we want to do quick deployments. So how can we do that? So let's say we have a very simple ASP.NET web application running the version 1 of the application. So obviously, as developers, we know things change. So you have the developer and the Microsoft Visual Studio they're running. So they're going to publish the new version of the software. So famous tools, they push this one into a Bitbucket or Microsoft Team Foundation server. I'm a great fan of that tool. So once you push that one, the continuous integration system is going to pick that changes. It's then going to call a build agent. So all these build agents, build systems like Jenkins, TeamCity, Microsoft TFS, VSTS, they have this concept called build agent that you can run on Apple Macintosh, on Linux, on Windows servers. So you run this build agent, which will have permissions to publish the image to Amazon ECR. So you attach that permission into that. And the build agent is running MS build, create the image, and then publish into Amazon ECR. And once it publish, it's going to call Amazon ECS, let's say using PowerShell, and then say, hey, Amazon ECS, I have a new image. Go there and then render this image, or go there and then orchestrate this image in Amazon ECS. So it's going to go there and then render this new version of the image on Amazon ECS. So after that orchestration, load balance is going to go through some health checks. Once the health check passes, it's going to direct the traffic into that the new set of containers. So that's how the continuous delivery pipeline works. It doesn't matter what kind of operating system, what kind of team build system that you use. As long as you have PowerShell, command line, or .NET Framework support, you can easily integrate with existing systems. So let's go for a demo and then see how this is being done. As again, the whole process of cluster refresh takes time, so I have recorded it and then create some presentation. So here I have my ASP.NET web application. It's keeping track of the name of the owner, the name of the pet, and how many steps the pet took. So it's like my cat in the house. They are not walking a lot, so that's why you have a few number of steps. And if you go into the info page, you will find the 2 containers back in this. So there's a load balancer, and it's doing round-robin load balancing between these 2 containers. So the ID that you see here are actually the container IDs. And it's running application version number 1. So obviously, like the requirements changes. So I'm going into my build system. This is how I have defined it. So this is Microsoft Team Foundation Server. I love the tool. So if you're already using this kind of system, you can configure your system like this. So I have defined the build steps. So the first step, of course, is to get all the content from your repository. It could be GitHub. I'm getting my NuGet packages, and then I'm going to add another step that will execute MS build task. And it's going to run your unit test, build it, create the image. So once it builds the image, it's going to be inside that build agent. Build agent has publication rights, so it's going to invoke this. So here I'm invoking a PowerShell command to publish this image. All AWS APIs are exposed in PowerShell, so you can easily integrate with your existing build systems. And then I'm going to execute a command line. So all AWS commands are executed in command line also. So if you are not a PowerShell fan, you can still use command line. So I'm going to tell ECS, hey, ECS, go there and render this new image on Amazon ECS. So what I'm going to do now is to make some modification into this web application. So instead of saying application version 1, I'm going to say application version 2 added new feature. So this is just a simulation of a developer making some changes and then trying to publish this software. So I make this change. Obviously, next step is that you are going to commit it. So just commit it, add some comments. Like normally, I don't know how many developers sometimes add comments when they commit them. So I push them. So what will happen is that it's going to go into TFS. It's going to run the build. So behind the scene, it starts the build process. Now I'm running the build process. You can find that my commands are being executed. Got the NuGet package. It's running MS build. As part of this MS build, if you have a very complex build process, you can still have cache Docker layers. So you don't need to wait for a long time, especially when multiple developers are coming to the same source control system. You will have like thousands, like hundreds of builds happening. And so once this image got built, it can sometimes use cache layers. So here you can find some cache layers are already being used. And so once you have this image built, it's going to tag that image with the ECR URL and then publish it. So the publication is done. If you go into ECS, what you'll find is that you have the old deployment and the new deployment. So the new deployment, of course, you need to first start the images in the cluster before redirecting the traffic. So at some point in time, still, if you go to the web application, what the people will see is the application version 1, number 1, because this new deployment haven't passed through some health checks. So this is the experience for a user. So they get the minimum downtime when you are running this kind of a deployment behind the scene. Still running version number 1, so far so good. If you go into your load balancer, what you'll find is that there are 2 containers, the new containers in initial state. And the old containers, one is draining, one is healthy. So at some point in time, this new container is going to be healthy, and the load balancer is going to direct traffic into that. So I can see that one container is healthy. So if you go and refresh your page, you should have this web application refresh to application version 2. I have fast-forwarded it. It takes some time for the IIS to get load. The DLS, the normal refresh cycle, is still there. And you now have the version 2 of the application. So that's how easily you can integrate your existing build system. It can be TFS, Jenkins, or any other build system that you have with AWS tools. As long as you have PowerShell, you can do wonders. So what did we learn today? We learned about Windows containers. You learn how, although the Windows image size are big, you can easily containerize your .NET application and run them at scale. They are production ready. You can run them on AWS platforms like ECS. You learn about Amazon ECS and ECR, why they are important, how they help you to orchestrate containers on a large cluster. You also learn like how you can integrate these permissions with ECR so that you can easily define, hey, these are production images. They should only run on production environments. We learn about best practices like login, exponential backoff. So these are the things that you need to apply when you are trying to modify your application to run in a container or cloud-native environment. Finally, we learn about automation, how you can integrate your DevOps tools like Team Foundation Server with AWS tools. Thank you, everybody. Value your feedback. Give us some feedback, and we can include this kind of .NET sessions in this one. Thank you. This is my contact details. If you like, if you have any questions, feel free to call me.